Hello. Da 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 da. The monolith. A thing of beauty, really. The big germ dove. That's him. That's germ dove. Fully rendered. It's incredible. There are feet. You can't see them. They're in the cup. It's a little secret. Oh, oh. Things what man were not meant to know. Monka TOS. So yeah, we can just do things with this, I guess. It's like, why not? Can we like really intensify that light? What can we do with light? Power, 1,000 watts? More. 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 Less diffuse. More specular. Less volume. I don't know. Just want to get that rim one. It's a victory screen right there. Little Toadette see didn't know. She wouldn't understand the implications. She'd be like, yeah, that's the dog. Yeah, that's the cat. Yeah, that's the fox. That's the little buddy. It's like, for her, there's very little difference between something interactive like a video game and just a movie. It's like the fact that things can be done with this doesn't she wouldn't know. Oh, that's horrifying. Hello. Hello. Hi. Oh, that's eerie. Equally weird. Some kind of Pikachu. I don't know. I have a laundry list of things I want to work on tonight and learn about, and we're just gonna see what we can get. I cheated a lot at this. This is just a mesh sitting here. It's practically a mustache. But it's good enough for the render. Alright, so first of all, this play zone is ridiculously huge. Like, to the point that it makes it hard to actually... Whoops. That it makes it difficult to actually, like, zoom in and pan around because everything is just so massive. Something else I tried is a ramp. And when I went off of it, weird things happened. Like, I flew into the air for a weirdly long time. And I think I finally figured out what the problem there was. It was just a difference of scale. Because originally, these traffic cones were somehow around the height of 2 meters, and we just never got that straightened out. Why can I not? Yeah, anyway, we're gonna delete some trees here. So I scaled those down drastically to hopefully a reasonable size, and then I had a better feel for how big the cart itself should be. Now that does mean that it's like zoomed in or zoomed out a lot more than expected, but it means we can like go off a ramp. And that works. I also did a minor change to the physics. Also, if you hit this dead on, you kind of like spin out, but it's like a purely organic spin out. It's not like a scripted one. So one major change is instead of applying torque when you turn, I am instead now actually manually rotating the car and then also rotating your current linear velocity. And I think that, I mean, that does help so that we can actually turn in a normal way instead of what was happening. Mostly. There's still a little bit. There's still a little to be desired there, but it's good enough. Whoa! You still do get a little bit of a spin out. Like a little bit of wobble. And you get some amazing... Well, I feel like I just kind of stopped there. You get a lot of air. I want to get these cones, but I can't see them now at this speed. That's another thing. We actually need to cap the speed, probably. Because as it stands, we just keep going faster and faster. Ooh, jeez. You do just keep going faster and faster. Yeah, like you get a little wobbly. The system gets unstable, I feel like. Did I clip one? I don't know. All right, I'm gonna take my foot off the gas. Now I'm gonna pump the gas a little bit more, speed up again. Yeah, see there? Yeah, you can kind of bonk those pretty well. But you don't just blast through them with no consequences. Like you do actually get a little bit. All right, these trees are huge now, aren't they? They need to be scaled. Show me the tree. All right, so the tree is... What is this? Wait, what is this? Isn't this the mesh, or is this the mesh? This is the... No, this is the old mesh. We don't want that mesh. This is the mesh. I do want to scale this down, though. See if that looks a little bit better. Scale-wise. Hey, maps. Okay. These do look fine now. Scale-wise, that looks a lot better. I changed the size of one of them because I couldn't figure out. I kept trying to resize the cones and then play the game and see what happened. And the cones just wouldn't resize. Like, they would appear resized in the editor until I actually started the game up, and then at runtime, they would snap back to their original size. Very confusing. I did a little digging. It is because they contain a rigid body. And that physics element cannot be resized because that does weird things to the physics. So it just doesn't. All right, so let's see here. So we scaled some things down. That's looking a lot better. I would like to allow reverse and mirror view. So I am going to want to get out an actual controller here, probably. That's how you know we're doing actual work tonight. Actually making some progress. So we are going to need a new action. Drive reverse view, which will be that. And also, I don't know, Q? Drive reverse view. That seems fine to me. And what that's going to do is that's going to pivot the camera to look behind us. It's not going to be perfect at first, because right now we are just absolutely setting the offset and rotation. What's the code for input? Drive reverse view, then reverse that view. We're gonna add pi to our rotation, and then our position needs to be not the same anymore. Previously, we would rotate our offset camera target position plus offset, except now instead of doing rotation, we're gonna do rotation plus pi, I think. Let's just try that and see what happens. Oh, not the button I intended, but that works. That is good. Whoa, if you hit a ramp at an angle, things get a little bit weird. That is another thing that I want to do is, right now, well, Okay, I can't even demonstrate it because I cannot get up a hill, apparently. That's noteworthy. Wow. That's rough. Well, on a hill, the actual mesh is not going to angle with the hill, and maybe that's not a big deal. We do, however... Okay, now that we got mirror view, we want to allow reversing. So let's see here. Right now, I say, if you are on the ground and you are doing the acceleration, then apply a forward force. And otherwise, if you're doing the brake input, this is where I need to change things up. I need to say, if your speed, your linear velocity, if your speed is greater than 0, then, well, let's reduce it even further. Let's say greater than 0.2, then reduce it by 20% this frame. Otherwise, start going backwards. Not too fast. Like, this will be a slow backwards. Let's try that. Okay, so there we go, and then stop. Doesn't work. Huh. Oh! Speed is... This will never be negative. Huh. Okay. Get out paint. All right, let's think 2D here. All right. If the cart is driving along, and then we got our wheels here. Vroom. beautiful. All right. And a seat. She's got to have a seat, too. All right. The car is driving along in some direction. We're going to say this vector here. I can get the length of that vector. But the car could also be driving this direction. In which case, either way, the length of this vector is a positive number. What I would like is, knowing that this is the forward direction of the car, what is my current velocity along this axis? Now, what gets messy is I could imagine situations where the car is moving off in like this direction, like it's kind of like side scooting along, I don't know, ice. I only want to know what is the distance of this vector right here, this blue line. So I have this direction in orange. I have that. I have that direction, and actually, I also have the magnitude of this, of its current velocity, but that could be anywhere. That could be over here. That could be straight back. Whatever. I want to reduce that to just its, so to speak, its horizontal component. But that may not actually be a true horizontal component, because this car could be going east or west or northeast or south by southwest. So let's see here. How do I do that with a vector? I have its rotation. That's one. I could do a little bit of trig. Is this what a cross product is for? I remember like nothing about cross products. I'm gonna go ahead and say no, it is not. Just looking at the explaining images, they go off in different axes. So let's see here. What could I do? I'm going to take this into Photoshop real quick instead. Just because I can rotate that a little bit easier. Come on. Come on. There it goes. I don't get why it takes so long to actually open the file. All right. So let's take this situation here where the car is moving up this way. I've got X, I've got Y, I've got Z, and I want the length of this along this axis. Well, let's even say this right here. I want this length here. That is not straightforward. Okay, I have the forward dimension. Because I've got this rotated forward vector, which is vector 3 forward rotated along the up axis by negative pi over 2 plus rotation dot y, naturally. So how are we going to determine our current forward-facing speed? How fast are we moving along the forward axis? Yeah, that's the magnet's axis angle. Formula to determine the magnitude of a vector. No, that's not what I want. I want the magnitude along a different vector. Find the component of vector A along vector B. That might be what I'm looking for. Oh boy, there is a formula. Wait. A cross product B. Oh boy, hold on. Vector component. I think this is it. Okay, a component. Angles to the customary coordinate. A useful mathematical trick would be employed to transform the vector into two parts. Yes. Okay, hang on. I think we're getting close. I think we found the right terminology that we're looking for. I don't remember learning components at all. Component along. Vector are more tightly lengthened definition apply. Okay, I think it is perhaps A cross product B divided by magnitude of B. Okay, hold on. That first answer seemed a lot more useful. This is game dev. It's all trigonometry. Along the direction of B. The component of A along the direction of B. So in my case, Photoshop. Hello, Photoshop. There it is. The component of A, the component of the car's actual speed, along B, which is the forward vector. Oh, see, I don't think the magnitude of B should matter in that case. Component of A along the direction of B. That doesn't feel right. Scalar projection of A onto B. Maybe I can find a good image. Scalar projection. Oh, I think that is what I want. Yeah, that looks right. That looks right. That looks better. That looks better. Magnitude of A times the cosine of the angle between them. That looks good. That looks good. Yeah, that uses all the things I would expect. Oh man, see the thing is, if I just assume that forward is theta 0, that does work out perfectly. The only difference is we have angles that are wonky, for lack of a better word. So let's try this as var forward speed equals. So this should be the magnitude of our linear velocity or speed times the cosine of the angle between them. Okay, the angle between our forward vector. Ooh, this might be a little bit tricky. How do we get the cosine. Maybe we can flatten these to vector 2s for simplicity. Oh, maybe. Oh, okay. So we can just do let's do minus forward vector dot angle. Apparently, we're gonna try it. That might be deprecated. Maybe not. It doesn't seem to be giving me a method there. Go for angle between two vectors. Angle 2, maybe? No. All right. Calculating angle between two vectors in 3D. Godot recipe, rotate, file not found. Cool. Smooth rotation. No. No, not quite. Ugh. Man. This doesn't feel like that should be that hard to do. Yeah, this feels like that should be fairly straightforward, right? Maybe I'm missing something here. I have a point. I have a point and another point and an origin. That's an ugly color. How do we wind up with this? And I just want to calculate what this angle is. That should be it. I guess I could calculate this angle and then this angle, and then that's good enough. All right, angle 2. Minimum angle to the vector in radians. Unsigned. Well, we'll see if that works. Ooh, this is a... All right, hang on. This got ugly. All right, var angle of travel. All right, how's that? Doesn't like that. Oh, takes, wait. Oh, it's okay. So it's like this. Oh, I guess I gotta do vector 3. Like that. That looks like that should be correct. Cannot call non-static variable. Make an instance instead. Oh. Wait. Oh, okay, so I can do this. All right. So I'm not going to actually use this yet, but what I'm going to do is just measure it for now and see if we get numbers that make sense. 0. Yeah, we should mostly be getting 0 here. Yeah, here's where we don't get 0, and that's fine. Okay, good. So yeah, that is what we expect. Angle of travel looks good. Forward speed then should be, yeah, we've got speed. All right, cool. Then maybe this will work now. All right, so stop. And it's not reversing. Okay. Well, also this is not the button I would expect. There we go. Our forward speed here. Just kind of hovering there. Don't think we're moving. Like we're getting some very, very slight movement. Apply force, -5. Oh, is it because... No, because this shouldn't be getting hit at all. This is not getting hit. This should be getting hit. Let's just try upping the acceleration and see if that works. Oh yeah, that's it. That's it. It was just such a small amount of force that it couldn't do anything. Oh. Am I? Okay. Oh yeah, it has some trouble if I'm just sitting on a slope. Ooh, also when going backwards, that doesn't work too well. The reversing direction is not what you would expect. It's reversed. Go figure. So when we're turning, if forward speed is less than 0, then multiply our, no, increase our theta by pi. Oh, dang it. Right. Still not used to the syntax. Whoa. Okay, let's change that to if it's less than -0.5. How about that? Huh. Oh. Not theta. Okay, no. Theta times equals -1. Which means this probably can be 0, but we'll give it a little wiggle room. Okay, forward, left, backward. Yeah, there we go. So now when I hold left, I actually get the directions I'm expecting. Okay. The steering snaps. Like, look at that. That's snap, 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 snap. Which is cool and all. Also, this max speed is... Whoa. This area will be a lot more fun to drive around when there's actually things you can orient yourself by. Okay, we got reversing. Next up, let's smooth out the turning a bit, I think. I think that's going to help quite a bit. So theta is how much we are adjusting our turn by. So what we're gonna have is like some kind of function of like a time spent steering. He's getting ready. He's getting ready. That is a creative use of emojis to make that happen. He's doing it! There you go. He finally did the funny floss dance. There was someone that came in on, I don't remember if it was Monday or Sunday, who said they may be able to help us figure out the bones. We will see if they happen to show up, and then pivot to work on that. But for now, we need to improve the pivoting of the cart. How you doing, Germ Dove? It's coated in yarn. Just a thin layer of little pieces of yarn. Alright. We're driving along. We start turning. And we're not going to immediately turn full speed. So we will let's see here. We'll have a turn. We're gonna do some kind of like turning acceleration, like how fast the turning takes effect. So that means that somewhere in here, if you are trying to turn, instead of turning you by this much, theta, which admittedly theta feels okay. It's a little sharp though. Instead, we will turn you by a fraction of that. Steer input. I want to make sure that if you change directions, you don't get this sharp turning anymore. That this is your target. This is what you want to be working up towards. So we're going to have a current current steer, and we're gonna lerp towards that. Oh my gosh, I've not been listening that long. All right, time for a shuffle. No, shuffle. All right. All right, so here's where we are going to accelerate towards that theta. Lerp from current steer towards theta. Wait. 1. Also, this is not where delta should be, really. If we're doing this. Instead, we're going to move delta down to here. Okay, let's try this. Whoa, I spun out. Pow! Whoa. You really do spin out, and I think it is purely physics-based. Let's slow this lerp down significantly. I still feel like I'm snapping. Also, brakes should, like, you should be stopped for a time before brakes work. Let's see here. Linear velocity dot length is less than 0.1 while braking, admittedly. Linear velocity equals vector 3 dot 0. Now let's just, yeah, that's probably fine. Is it? No, let's do this. If you're on the ground, if your linear velocity has been less than 0, then how did I stop the timer? Let's take this over here. Stop timer has to be more than 1.1 second. Just 1 full second stopped. Okay, now I can no longer reverse. What's my current? Why is that the case? Let's find out. Stop. Oh, because as soon as I start moving backwards. Okay, that's fair. So I really want to know about my forward speed. Yeah. Stop. Okay, bring that threshold down for brakes to 0.5. But yeah, that's much better. That feels a lot better. Because now you don't immediately start going backwards when you stop. There's like a half-second pause so that you can actually like come to a stop, and then you can choose to actually reverse after that. Stop, and then reverse. Now the acceleration of that reverse is a little bit strong. Okay, this speed change does not feel right. Linear interpolates between two values by the factor defined in weight, which would be between 0 and 1.0. From and to must be the same side. Okay, so we're moving from... That's what I thought. We're moving from our current steering... Duh. That's why. That's why. Okay, well this is probably harsh. Too harsh now. Probably not going to turn at all. Ooh, that's slippery. But yeah, that is what I was missing there. All right, let's bump that up a bit. Okay, so that could be a nice handling value. Oh, that feels a lot better. Okay, we're still going way too fast. Pretty sure I just clipped through a cone. Bam. Got it. Whoa. All right, cool. That works. All right, let's hit the ramp side dead on and see. Whoa, yes. That is like, I didn't program spin out, but you do. You just spin out. Okay, max speed needs to be a thing. Max speed does need to be a thing. So part of that might just be on the physics here, the rigid body. No, we didn't mess with the inertia, did we? I mean the friction. Though we are still listed as 1 kilogram, which seems a little bit on the light side. Oh yeah, because if I bump it up, then I can no longer move. So there's that. So we'll leave it as is. We have a 1 kilogram cart. Don't worry about it. It's fine. Maximum speed. Let's think of a good way to do this. Set a max velocity on a rigid body. Now, first off, is there anything we can do with that? Is there any way built in for that? Physics process, you clamp. Oh, that's it, huh? Wow. Okay. I don't know what our current speeds have been. let's just debug that. Find out. Something feels a little bit different. All right, well, this feels way too fast and way too slidey. Yeah, maybe we say like 40. Oh, because I undid that. Whoops, haha. All right. So let's try just clamping max velocity. Now the thing is, this is more of... I have to remember that we probably want to add some kind of speed boosts at some point. So it's gonna be more of like how this is gonna work. So what if we just say instead, if forward speed is less than max velocity, then we can apply the force. And have a separate max reverse velocity that's pretty slow. Like 10, maybe less. And it's got to be greater than negative. All right, let's see. So first off, let's try to go backwards. Oh, that's good. That's good. Okay, feels pretty good. Yeah. I'm not out of control fast anymore, which is great. This is not bad right here. I'm kind of digging it. Now, there's the matter of this ramp issue, which we're going to have to figure out how in the world to get the physics to play nice. But right now, I think the problem is this right down here, this axis lock, is preventing us from rotating. Let's turn off the X-axis lock, and this will let us kind of rock forward and backwards. Let's see if this helps us a little bit. Oh, ooh, that doesn't feel like that's helping. That doesn't feel like that's helping at all. No, that's the opposite. How's it doing that? Why is it rolling over? I thought we said we were taking off the axis lock, or not. What axis is it turning on? Let me see that again. Where's your, Huh. Well, what if I lock only the X? That doesn't, no, that should, if I do this, this should roll over immediately. Okay, I think it's got some confusion on which axis is X and Z. Like, is this because I've got this rotated in space here? Is that the problem here? Let's, just for the sake of argument, let's try that. Nope. See, it's wobbling now. It's wobbling a lot. Huh. Huh. But without turning, will it handle this better? No. In fact, it handled it very flatly. X is forward here, and X is to the side here. Is that why? Yeah, actually it is. That is why. Huh. Yeah, look at that. Axis lock. Something screwy here. Axis lock, rigid body, rotation. That's goofy right there. That's not what I wanted to do. For the record, that is not how I want this to work. Oh well. Turn them out. See, I'm only messing with rotation Y here. So I don't think that should be an issue. It's fine. All right, we got max speed working. I would like to have... I would like to have slopes working better. But that's really hard to do as is. So it's kind of tough to see, but the cylinder here is the true cart. If I add a quick mesh instance here of type capsule. Okay, no, third time's the charm. Here we go. All right, so right here, this capsule is the actual hitbox shape of this. But as you see, it doesn't like bend up with the slope there at all. And that's kind of by design. And also that does, yeah, that's something I'll need to work on right now is if you're above a slope, it doesn't really count you as on the ground anymore, which is not good. Whoa, okay. Which I can actually probably fix that grounding issue without too much of a fuss. The code I've got for that is simple enough. I take the origin and I query downward and see how far it is. And the origin of the cart is dead center at the wheels. So what I would want to do then is say checkpoints. Just for clarity, I'll add those. Okay, here's the questions. Does this work? Does GDScript support this? Seems to. That does not work though. Is it this? Is this what I need? How do I do a for loop in GDScript? How do I do an array in GDScript? We will find out. Looping. Very common thing to do. We're learning, we're learning. Okay. In range. Okay, yeah, you can do for checkpoint in like this. That should work. Oh. Why didn't it work when I used a variable for that? I don't like that. Well, I guess it's fine. So we're gonna say if result size is greater than 0, return true. And if you get to the end of the loop, return false. Okay, this should help. Plus vector 3 dot. Ooh, I don't know about this. Forward vector. What is our forward vector? Apparently it's this. Times point. I think that'll work. This should improve our ability to go up ramps slowly, maybe, because it'll actually know that we're on the ground when we're up here. All right, hold on. I need to add a print is on ground here. All right, right now we're on the ground. Yep, we're on the ground, it's true. Okay, so right here. Okay, it does still, oh, nope, right there it doesn't. Whoa. All right, it had some moments there where it did not think we were on the ground. I don't like that. Why do you not think I'm on the ground here? Yeah, right here, it doesn't think I'm on the ground. Why? You know what? I'm worried that this angling here is wrong somehow. I'm just gonna try this and see if this makes a difference. I'm hoping it doesn't. Yeah, we're still seeing I don't feel like this turns sharply enough. Well, maybe it does. I don't know. Yeah, right there. It's not saying we're not on the ground anymore. Okay. Let's drop this checkpoint idea. and instead just increase this direction to check. Wait, position plus... Okay, what is position here? That's my midpoint, saying start at 2 pixels up from there and go to 2 pixels, or 20 centimeters down from there. Let's bump that up, maybe? Will that help? That did help. I stayed touching the ground for significantly longer. All right, maybe that's good enough. I don't know. It's like part of me wants to try the toy marble solution just because I feel like the physics would be a lot easier to manage. Because as it stands, we tilt over a lot. But I want to be able to like be on a ramp. Ow! Welcome in. How was space? Deader than ever. Oh man, that's unfortunate. Ow, we've already done so much tonight. It's you can ignore the big sphere, the big cylinder thing. Outrage! All right, so first off on the to-do list, everything needed to be scaled down by about 4 times. Because physics was weird because everything was like the size of a house. So when you went off a ramp, you would really just take a long time to land because, you know, gravity doesn't scale as well. So everything gets scaled down. I haven't adjusted the camera to match. You can now reverse, and it actually like pauses a moment to let you do brakes first. To fit with that, I added a reverse cam you can switch to. It looks like driving. I've smoothed out the steering quite a bit, and as a result, it feels pretty good. There's a speed cap on both forward and backwards, and they're not the same value. You can still spin out after you go airborne, and it makes you feel really out of control when that happens. I want the tracks to have verticality is the thing. And I'm worried we're not going to be able to do that too well, but we'll see. So here's our little makeshift ramp. Which maybe if I just kind of like really reduce the rampitude of that, maybe we'll get a feel for how much sloping can we do before things break down. Yeah, like right there, I just really lost control. Actually, right there, I lost control when I let go of the gas. So that's weird. Don't quite get what's happening when that happens, but... yeah, it's getting there. I think it'll be a lot better when we actually make a level, which we could start that tonight. Like, maybe with the assumption that slopes will work someday. The physics, I don't know. I'm not crazy on board with how it's working currently, because, like, that, I didn't do that. It's kind of slid off into weird space. I guess with physics, there's pros and cons of using actual physics. Like on one hand, it's like you get kind of this emergent stuff like traction and weight and friction and inertia, and it's all built in through the magic of physics. and gravity, for that matter. But at the same time, the system may be like, look at that. I just wound up turning right while turning left. It's slowing down because there's like that happens with physics. Like a car can actually spin out. It's not turning, but then it can just kind of whoa. So it's like that's a thing. Also, things like bumping into things is good. So I'm not 100% sold on physics. No, and I mean it's not really supposed to be anything. You know, it's just gonna be what it's gonna be. Let's bring this camera a lot closer and see what happens. See, I feel like I want the camera to be lower down and tilted up more. That's better. We can tilt it up here. If I can find it. Yeah. See, look at all that beautiful sky we can see now. Cone. Yeah, right now when you hit a cone, you hit a cone. Yeah, it's like maybe all we do is just set velocity of the rigid body manually. It's like I still want to get things like, you know, my object gets stopped by solid walls. Let's see, what is, so you can have, in Unity, you've got, like, kinematic versus static versus, what was it? Kinematic versus dynamic or static, that was it. So kinematic is entirely script-based. You have to manually handle motion. So maybe there is a kinematic sort of physics. Collision. Let's see. Godot. Kinematic 3D. Meant to be used. Hang on. Kinematic bodies are special types of bodies that are meant to be user controlled. They are not affected by physics at all. The physics will compute an estimate of their velocity. Oh, this is what we were using before. I'm not sold. Like, I want something that has physics. Crazy as that is. I mean, I guess, do I need something? I think the only reason we really switched to the rigid body in the first place was we were seeing some really weird stuff with the cones. All right, let's go off the assumption that, yeah, we're gonna have slopes, we're gonna have ramps. We just don't know what we can get away with yet. And that's fine. So let's just do that. So the scale of our cart here is 1/3. So we got a 2-meter long cart. Oh yeah, speed boost. Power-ups, I don't even know, because I don't even know if we're gonna have multiple carts running around on the track at once. That feels like that's gonna be something for sometime in the future, but Dupu, what are you doing here? Get out of here. Get out of here. Dupu jump scare. There we go. Good old cube. There! Alright, so this is roughly our cart. Can you place another object? You can. So let me grab my Blender Learning cart 2. Alright, that's fine. It's the size. It's the right size, at least. We can delete these. Delete that. And we can just join all these together. We'll put these in a collection. There we go. This is just for scaling purposes. There we go. All right. So we've got a rough size of our cart. Let's build a level in Blender, and we can export the model later. Topology. Guess we want a plane? But like a big plane. Right now it's the size of our cart, which doesn't leave much room for driving. 100 cart lengths doesn't seem like that much either. How big is this? How big is our ground? 500 units. And if we just go in a straight line, it'd take us a little less than 20 seconds to get across the whole distance here. Yeah. So 500 by 500 would, you know, be like a small track. And we probably want a little bit of room for decoration on the side. So let's just make it a kilometer. That is daunting. Oh, that's too big. That's too big. All right. 6. There we go. All right. Now what? Never made a plane. Subdivide, right? Subdivide it enough. Go make a nice big mesh, and we can. All right, this will be a good start. Yeah, let's just. Yes, I'm still listening. I assure you. No. Oh, yeah. Mount Wario. Wait, replay version? No, give me... lap 1. I forgot that there's, like, different songs for each lap. The only way. I want every pixel of this track to be its own mesh. Let's see here. I guess I want sculpting mode for this? No. Surely not. No. But I do want proportional editing. Here we go. This is what I'm looking for. This is proportional editing. This is what I want. Yeah, there we go. Look what I can do now. All right. Make some hills, I guess. While the transform tool is active. Haha, there it is. That's what I was looking for earlier. I'm still in Photoshop mode, so I was thinking like square bracket. All right, we get some nice totally enclosing mountains. We'll bake in the illusion of distance. How big is our cart? All right, think about it. Yeah. This is good. We may have to lower our max speed on the cart again. And we'll add like a subdivision surface to it. Photoshop is my jam. I've used that for a long time. 20 years on the same version of Photoshop. All right, what are we building? What's our theme here? Let's not. You know what? We don't need one. Our theme is a go-kart track in a little valley. This is our first track. It doesn't need to be very fancy. Oh, this is how you extend this? Come on. It's better. Oops, not sure how I did that, but that's fine. It's meant to be a little irregular. Our tiny little light. Wait, no, we want sun. This should be a sunlight here. Sun. Ah! Ah, shoot. Too bright. One sun. One sun. All right, there we go. Looks great. All right, so, yeah, we're just gonna do I guess we're just gonna do a little track in the middle. Nothing crazy. Curve tool to define the track shape, and then maybe extrude or not extrude, but we can match to curve like a basic track. Wait, isn't there a tool in Godot itself for this too? You can stand a profile. All right, let's build a profile for our basic track shape. Oh man, with this, look at this rotation distance now. I guess because I made the plane so big that that's just what it's gonna do. All right. All right, this is gonna be easy though. Oops. Why is this moving with, no, I don't want you selected. I'm just moving this. Why are you part of this? Why do you think you're included? Why are you included? Oh, I added it to that somehow, didn't I? I had that selected. No? Sorry, what? What have I selected here somehow, magically? Add a cube to the scene. That's... yeah, you got it. Yep. Dang it. That's it. Ah ha ha. Okay, let's start with, let's add a mirror across the y-axis with clipping. Oh, not its own axis, I meant across like the origin. Well, it's fine. It's fine. Okay, plenty of room to start with. And then we will loop cut. Oop, nope, sorry, cancel that. I'm having trouble panning around right now. Hello? All right, I mean, that's fine. I'll work with that. Oh, it's the stump. There's the mirror in play. Okay, there it is. Okay. I do want to kind of add it. All right, mirror it by the dump cart. It's fine. Hello, clipping? I like the way it's doing the clipping that I thought it was gonna do. Huh. Well, that's fine. That's just a thing that happens, I guess. All right, screw the mirror. Apparently, I've completely forgotten how that works. I mean, that's it, right? That's basically all we need. What more would we want on this? Maybe I will add the mirror. All right. Sure, it's good. It's fine. Yeah, that's track. Okay, we're gonna try and do a curve. I've never done the curve before. Start with 150. Is that what I'm missing? Let's try that again. All right, let's disable the mirror. The viewport. All right, edit. Give me these faces. Or give me this. Give me these vertices. Oh. Okay, give me just this face. Simba. Wait, I think I have a better idea for how to handle this. Like, I think if I mirror it around the cart, this dumb little cart that's sitting here. Well, okay, so the cart is not super well centered. Can I just get a world? Can I just mirror around world origin? I mean, I guess I can if I just do this. Add a plane, 1 meter. Mirror this around that plane. Create an empty. Well, I created a plane. It's fine. With clipping. So, ideally... No, maybe not. I thought that would work. It's fine. Okay. Let's take these vertices and just move them somewhere else. Oh, there it goes. That's what I wanted. Yay. It finally did the thing I wanted it to this whole time. Okay, and now I should be able to delete the interface and confirm that we have there it is. It's beautiful. Merge distance is what I was looking for. Gotcha. I'm gonna go ahead and apply this. I don't want to even approach the possibility of things going terribly wrong. Okay. Circle. Look at this. Oops. Oh, I see. Now, can I add more? All right, let's delete the circle, and then add it again. Because I assume no. Thought maybe I'd be able to add more points. Maybe that's only a raw curve. Where is this? Ah, there it is. All right, let's see what happens here. Let's snap to grid. Grid snap. That's not doing what I thought it would do. That's fine. By subdividing. Ah, see, that would. Let's do that. It's my first time using the circle, if you can believe it. Subdivide. More, more, more. Let's do 6. Do I need to select? Ah, there we go. You know what? Let's start with just let's start with no subdivisions, so that we can just work with just this. Then we can do like this, and this, and I don't know, this. Then we can subdivide. Oh wait, select all, subdivide one time. And now we're just gonna wiggle around a little bit. Yeah, look at this. Just wiggle it around a little bit. GQ, you getting excited for Dabble Cart? I know you are. And then we can also do like these kind of things here, if we so choose. To bend it more or less out. Ah. Oh, and I'll want to snap these to the face, maybe. Let's see here. Snap to face. Snap to face project. I think. Because that way we can kind of get it on the surface a little bit better. And we'll direct the we'll direct this around. from the viewport. That should be fine. Oh, to kind of stick it on to the playing field a little bit. That's worth a shot. And you know what? Let's consider the possibility of like a tunnel at some point as well. Gotcha. I mean, you've got me beat. Which doesn't take much. Let's make a new folder here for track1.test. All right. So I think let's do this as a test here. Cube, which is our track piece. We can modify this. We can... Okay, here we go. We want to make it follow the curve, right? Curve object is this. That didn't work. Oh, is it because it's not... Is it because it's technically not a curve, it's a circle? Does that matter? Does that actually matter? No, just, well, hang on. Array curve is complex. So you need an array and then curve the piece to the curve. So these modifiers should be on the track. Okay, I'm on the track piece now. And I want to add, I assume, a curve deformation. Or no, I guess an array first and then curve. So array on the x-axis, fit curve. Nope, that didn't work. Array to length of curve, then curve deform to track. Okay, so array to length of curve. I don't think it's finding any curves out here for this. Just to test. I'm gonna add just a sample curve here. Just to see if it's cool with this piece. If I were to array fit curve. Oh, now it shows them. Now it shows them. Never mind, we're good. Adding the curve. Oh, maybe that's it. Maybe, I mean, I am in object mode now, and that seems to be working. Also, we're not going to want this to be this thin, by the way. Whoop, too big, too big. There we go, that's probably fine. I put the modifier on the circle. What? No, track piece, right? The wrench is still on the other curve. Oh, I've still got this on here. Let me get that off. There we go. Good catch, good catch. Okay, so now that I've said fit curve on the circle, and I'm gonna get rid of this now. So let's play around with this. What does this do? Fit the duplicated objects to a curve. So now, secondly, we add the curve modifier. And I've seen this. I've watched a lot of tutorials, you guys. I haven't taken much from them. There it is. There it is. Okay, okay, so that's a great start. Wow, that is a little wobbly, and that's fine, because we can smooth that out. Beautiful. We have a racetrack. It's a little clippy, Don't worry about it. And so, yeah, array is not merging, and that's got to be this. Yeah, look at the difference there. Whoop. Never mind. Don't look at the difference. Oh, okay. Don't need caps. Wow, I know, Al, right? Just like that. Like, this is a super lazy way of doing a track. Like, I'm just slapping a mesh into a landscape. But it's something. Okay, okay. And so now maybe we can deform and offset. Nope. You know what? I don't think that's exactly what I wanted here. Shrink wrap is a hot mess. Now wait, hang on. Let me try something really dumb. Let me try something really dumb. But what if I did shrink wrap to this? Ooh. Remember how I said it was really dumb? Okay, wait. There's something else I vaguely remember. Nope. Never mind. Maybe not. Nope. There is not. And that's fine. That's fine. Like, as is, we've got some easy options for fixing this. Like one, just pick it up. Whoa. Whoa. That's weird. Oh, I've still got this snapping on. There we go. Like, one thing I can do is just pick it up. Offset it a bit. Actually, that's not a terrible idea to start with. Just to experiment. Real quick. Slap a material on here. Don't even worry about it. Ah, good call. Let's see. The button for the information panel was something weird. Maybe this tiny arrow. Okay, I don't know. Okay, so track. Here's the curve. Whoa. All right, yeah, I'll just move this. I'll just have it offset from the curve a little bit. It makes sense, makes sense. This is gonna be awful, by the way. Just if anyone's wondering. All right. Let's throw it in and see what happens. Oh, wait, I forgot a thing. Export. Make sure to apply modifiers. Or that's gonna look really dumb. Right. luckily, this is just kind of a quick test to see, you know, what in the world happens here. Let's make a new scene, maybe. All right, track 1. Load it in. I don't like the fact that it's got an X on it there. Oh, well. Oh, dang it. I left the car in. My little sample to confirm that things were the right size. Oh, man. Final 2. All right. Delete it. Delete it. Pull it over again. Okay. Okay. Here we go. All right. Cool, cool. All right, what else did we have on here other than a bunch of weird trees in the ground? We got a camera, a cart, and a directional light. Wait. This. Nice. Move that cart. Intersect it somehow. Where is it? Oh, there it is. There it is. We're in. Track 1. Camera target, player cart. I may have forgotten something, guys. All right, collision shape. Oh, this is gonna be tricky though. Can I use? Ooh, forgot a big thing. Godot, use Blender for. Let's see here. Okay. So wait, so what I really want. Just the mesh. I want to create a collider the same as the mesh. Oh boy. Load. Oh. Tress, res, or shape. Tress, res, or shape. Let's see what we can export as. None of those. You need to name your object with -col in Blender. Really? Or just export it as an OBJ. Mesh. Okay, I'm gonna try this. I'm gonna make it an OBJ. This guy says that what he did imported the OBJ. Okay, we got that. Can I just use this as the shape? No. Can I use this as the shape? No. Okay. Select the mesh. Well, let's do this first. Oh, see, that doesn't have the stuff. So let's do this. Track 1. Add child node. Mesh. No, this is a mesh, isn't it? What is this? What did I just load here? All right. Mesh instance. See, that doesn't go there. But it can go there. But then it loses the surface materials. But I can pretty quickly just kind of make it close enough for now. Yeah, we'll just do a good enough for now. Remember, we're just learning real quick, and then we're out of here. All right, create a mesh, and then click mesh. Create simplified convex collision. Wait, was that on this as well? It was not, weirdly enough. Create simplified convex collision shape. Well, let's go with this. Oh, see, that's probably not... No, that's not what we want. Try mesh. Yeah. All right. This is probably not good. Okay, what's the warning here? Only use it as a child of. Well, fine. This is almost certainly not the way to do this. Right, rigid body in static mode. Where's static mode? Godot, rigid body 3D, static mode. Where is it? Static body freeze mode? Oh, okay, I guess that's it. That's not it. Freeze mode static. All right, it's in static mode now. I put it in static mode like you said. It's in static mode. What's wrong with that? It's not gonna let me, is it? Oh, well. I'm on a road. Whoa, I'm spinning out because I can't go up hills. Because we already established that is a thing for some. That looks good. I'm going downhill then. Can't stop me there. Ooh, you can stop me there. 0% traction. I don't need traction. I need speed. Whoa. Okay. See, it's working. Whoa. These rocket boosters, you bet I do. Whoa. All right. See, the handling is it's a little rough. Oh, you know what? I'll just go backwards. Nope. If you start to spin out, just immediately hit the brakes. And then go backward. And see, then when you spin around, you'll be facing the right direction. Oh, that looks really good, doesn't it? Well... Why is this one so quiet? Oh yeah, it's a little bit. It needs some love. Oh, okay, that's fine. It's fine. Hang on, we're going uphill. Our one weakness, more than a 2% grade. All right, we're going this way now. Don't worry about it. Oh, no, we're not. We are going where the cart wills. Oh, gosh. I gotta be honest. It's a little hard to control. All right, hang on. I'm gonna fix it. I'm gonna fix it. This is fine. All right, here we go. This will work. You'll see. You'll all see. It's gonna be the next getting over it. All right. That's not the loop point. That's not the loop. What are you guys doing? All right. Get rid of this. Get rid of this. Looks good to me. Great, great.
You just got coconut mauled. Share this with all your friends to totally coconut maul them.
I can't believe you do this to me. All All right, so what do I need to do again? Right, mesh. And then just pray. That's not good. I may be in the wrong spot. Ah. That looks good. All right, now we're ready. Whoop. There's still a slight gradient here. So I flattened the track by most of it. Uh-oh. Uh-oh. That's not good. Well, now it's open world. Usually gotta pay more for that. Whoa. Ooh. Oh boy. Why is it so spinny? All right, there we go, guys. We did it. We made a good video game. Thank you for joining me on this 30-part series. We're done. Possibly, it only weighs 1 kilogram. So it's not out of the question. Thing is, if I bump it up to 100, I need to vastly increase the force of the acceleration, because I'm not controlling it directly. Nope, that doesn't seem to have done much, as it turns out. It was worth a shot. Rough on. Bounce. No. Absorbent on. I don't know what any of those do. Let's find out. Nope. Turned friction all the way up. Whoa. Remove that. Change this to... Oh, you know what? This will probably help. Fast mode. Whoa, that's not helping. Ooh, it's not helping. I've turned on high speed, and now it's high speed. I only quintupled it. So it's cool that we do have a track technically now. It's impossible to use, but oh, here we go. We're on the flat part now. Now we can go for a ride. As long as we stay away from those hills. Oh no. This is great. Yes. And I'm curious if that's part of the weirdness of the physics, is that it's kind of trying to stop totally normal physics things from happening, which makes things go a little bit zany. Or maybe this is just how cars work, and you've never raced a car this fast before. It's good. It's good. This is how cars work. This is just the way of things. Oh, no, not the edge. Brake, 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 brake. Vast world behind me. We don't use the roads. They're too high up in the air. Exactly. Now, obviously, if we were to actually make this into a playable game, that's the one. Add blockchain. There would be supports, and we'd add some kind of reset plane right below the road so that if you fall off, you get put back on. Oh, jeez, this is so awful. In the best way. It is so hard to control. It works okay on flat ground. That's what, if you fall off, you're gonna feel it. Okay, so this has been a learning experience. We actually did some good stuff, and I learned about the curve modifier. That was actually my first time using the array modifier in Blender, which I feel like that's something I would use a lot more than I do. Mirror, I'm still like a little iffy on it. I still don't quite have it down, but we're getting there. Yeah, it's the kind of thing I'm like, oh, I want that in Photoshop. And, I mean, I know that modern versions of Photoshop do have that, but you can have my CS2 when you pry it from my cold arc text warped hands. Dang! Things are going great! We fell off the racetrack! Okay. I think the next priority needs to be now, we need to actually work on the physics. I'm not even turning. I'm just holding the cast down, and this is what is happening. You can see from the shadow that we're like getting little jumps here and there, or big jumps as the case may be. Hang on tight, chat. We're going for a ride. All right, here we go. No! The void. So cold. All right, here we go. All right, chat, I'm not going to look. You have to direct me. Onward to the finish line. How we doing? We okay back there, everybody? Chat? We good? Are we good? Okay. Oh, right. Okay. I will turn this car around, Jay. Dupe will stay in your teacup. I'll turn this car around 45 times in 2 seconds. Well, this has been a treat. Okay, so imagine then we build a track like this, but maybe it's like on the ground a little bit. It goes through some trees and more natural barriers instead of like massive concrete walls. Chat, clip it. Chat, post it. Post it to the Discord. Chat. Give me a back rub. Some kind of big, like, thing in the middle to be like, oh, it's the centerpiece of the track. It's the point by which I can orient where I am. All that. That's what you need. I've got a few ideas for thematic ideas of like, oh, we're gonna have the rover space level. We're gonna have the, you know, different little fun thematic levels. I say we're going to do all this stuff as if we're actually going to do all this stuff. We're gonna be lucky to get that far. We'll see. Welcome in, Short. Short, you missed something. But yeah, we absolutely need to get the physics better. I'm thinking of taking the rigid body and just chucking it out the window, and we just do it ourselves. I took it for a try. I did. Actually, maybe player cart can stay a rigid body, but we just lock all rotation and manually rotate. Maybe that's a thing, because like I can't think of a situation in which we want the cart to rotate on its own. I love Zode's precepts because they initially sound dumb and self-congratulatory, but then it's like, wait, there's actually something there. Especially within the lore of the game. He's got lore in there. It's like the Sun Tzu level of like brilliance. If your enemy is strong, try being stronger than they are. So, that's brilliant. Oh. Well, this was something. This was a night to remember. All right. What is the chance we're actually going to manage to find somewhere to go in the next 10 minutes? That's not where it loops. That's not where it loops. Let's see. Cat makes. Mangor. I know so few people. That's just a picture of a chair. That's not a stream. That again is Halo, not Mario. A ferret rescue stream. Oh man, are we going to the ferret rescue stream? What else we got? Gotta check the Mario Maker category, because I know how much everybody loves Mario Maker. I love Family Guy. You get it, you get it. Do they? I knew a guy who had ferrets when I was growing up. They smelled unique. They stink. Pirate Software. I recognize Pirate Software. I get a lot of recommendations. Not from the concept of pirated software, but from the user. Pirate Software. Okay, if anybody wants to go watch the ferrets, go watch the ferrets. I feel like rating the ferrets does not do much, because there are almost 400 people there. Same. I'm terrible at rating. I think the trick is I need to end stream like 30 minutes earlier. Okay, recommended channels. Here we go. Recommended channels. Dark Souls. I've never watched a Dark Souls 3 stream. Why am I recommended Dark Souls 3? Twitch. What? What even? Okay. Against my better judgment, software and game dev category. Nope. It's just a wall of gray with text, and then occasionally just a close-up of somebody. I mean, admittedly, this is gray. I mean, that's just what these streams look like. You like Stardew Valley? How about Elden Ring? We're not raiding. We're not doing a raid. We're going to bed. Big surprise. Yay, bed. Joke's on you, bot. I've already made the call. Alright, notes. We're going to experiment with... You might like Pen Pals. Pen Pals! Now on sale. Get it on Steam. It released December 1st. It's $2 right now. Buy a 10-pack. Give it to your sweetie on Valentine's Day. I'm Control Zing through my track changes. It's Palant. Ah, Palant. Ah, I missed it. I went with Valenswine. It is Pinpalantine. It was right there. Also, I screwed up the Steam announcement because when I told it what I wanted to do, I said game discount, but I also wanted to do an update, and it gave me all the usual stuff for put in your update information. And then I don't think it showed up on a lot of people's news feed on their game list. But I can't really confirm that. But it gives you all the juicy lore. But that's what it is. It's a learning process. That's what we're doing all this stuff for. We're learning how the systems work. We're getting better. All right. Redo physics. Lock. Rotation. I mean, maybe that's the point, Day. Maybe we want to get the confused person in a hurry at the store to buy Pin Pals. Buy Pin Pals. Buy Pin Pals. Buy Pin Pals. Good night, everyone.